Okay, folks, welcome to 4.6 Part 2. We're going to talk about solving log equations in this half. Just like last time with the exponential ones, we're going to go through 6 examples just to kind of talk about a few different types of questions that tend to come up, okay? So we're going to start with this example right here. We have log of 5x plus 1 equals 2 log of 2x minus 3. Now, I just want to put a little number here that's missing, just as a reminder that when we don't see that base, and it's a log that is actually a base 10, and that is our common log, okay? Now, what we're going to do here is we're going to use a little bit of algebra and some of our log properties to turn turn 2 logs into 1 log. So I'm going to go ahead and subtract this to the other side. And that's going to give me log base 10 of 5x plus 1 minus log base 10 of 2x minus 3 equals, the only thing remaining on the right-hand side is 2. And now we're going to take these 2 logs, and they're separated by a minus sign, so I can use my quotient property to combine those 2 logs into 1 log. And so I'll get log base 10 of 5x minus 1 over 2x minus 3 plus 1 over 2x minus 3 equals 10. Now, once we have isolated our single log, we're going to go ahead and rewrite it in exponential form. And so that's going to give us our thing that we're logging equals the base to the power on the other side. And we can turn that into 100 right here if we'd like. And what we're going to do now is we're going to go ahead and take this 2x minus 3 and we're going to multiply it to the other side. So we'll get 5x plus 1 equals 100 times 2x minus 3. And I'm going to go ahead and distribute that 100, so I'll get 5x plus 1 equals 200x minus 300. And let's go ahead and combine our x's. So I'm going to go ahead and subtract the 5x to this side, and at the same step I'm going to add the 300 to this side. So I'll get 301 equals 195x, and our x is going to equal 301 divided by 195 as an exact answer, or about 1.544 for an approximate. Okay, so exact and approximate. All right. These kinds of questions are really good to review for the uses for log properties because without the log properties, it makes it a little bit harder to solve. Okay, let's take a look at another example that uses log properties. All right, so you'll notice that this time I've got 3 logs, and again, those bases are missing, so I know that they're 10s. I can go ahead and put them in there. And maybe even write a reminder to myself that this is talking about the common log. Now, when I have more than 1 log like this, I'm just going to go ahead and keep the log on this side by itself, but I'm going to take these 2 and I'm going to condense them into a single log on the right-hand side. So that'll give me log of x minus 1 equals log of, when we're adding, that is our product property for logs. So I'm going to take my 2 over x, and I'm going to multiply it by my 3x minus 5. All right, log of x minus 1 equals log of 6x minus 10 over x. Now this one is actually really nice because I've got a log on both sides. All right, I've got a log here, I've got a log here, and even better, the base on this side and the base on this side are the same. And when I have a log of something equals the log of something else and the bases are the same, I can just take the thing that's being logged on one side and set it equal to the thing that's being logged on the other side. And now I get a situation where I'm just going to take this, multiply it here. I'll get x squared minus x equals 6x minus 10. And good thing we just did all of that quadratic work with our exponential equations, because it looks like we've got another quadratic here. We'll get x squared minus 7x plus 10 equals 0. This one is factorable, so we'll get x minus 5 times x minus 2 equals 0, and x equals 5, and x equals 2. Now, we really want to make sure that when we plug our answers back in that they're both going to work. And when you plug in 5, it does give you the same number on both sides. And when you plug in 2, it will give you the same number on both sides. So both of these are our solutions for example number 2. Okay, let's move on to a different flavor of log equation. So for example number 3, you'll notice that I have log that is the square root of x, and then on the other side it kind of looks the same, but it's not. I have the square root of the log of x. And so what I'm going to do is I'm going to go ahead and take this square root on this side, and I'm going to write it as a power for the x. So that's going to give me log x to the 1/2 equals, I'm not going to do anything to this side yet. The other thing that I know about my power is once I have a power, I can actually bring it down as a coefficient. And so that's going to give this left-hand side to be 1/2 log x equals the square root of log x. Now, how do I get rid of this square root situation that I have here, this guy? I can get rid of a square root by squaring one side. But if I square one side, I'm going to have to square the other side. And so when I do that, I end up with 1/2 log x squared equals log x. Now I'm going to go ahead and take this square, and I'm going to square that 1/2. So 1/2 times 1/2 will give me 1/4. Log x is squared equals log x. Now, I don't really love working with fractions, so I'm going to go ahead and actually take my whole equation, and I'm going to multiply the whole equation by 4, because when I do that, it's going to get rid of the 1/4. I'll get log x squared equals 4 log x. And to me, it's just a little bit easier to work with, but you certainly don't need to do that if you don't want to. Now what I'm going to do is I'm going to subtract this to the other side. So I've got log x squared minus 4 log x equals 0. And I notice that I've got a log x here and a log x here, so I'm going to go ahead and factor those out. Log x times log x minus 4 equals 0. And so I end up with log x equals 0, or log x minus 4 equals 0. And when we think about how to solve those, we can rewrite them in exponential form. In this case, I'll get x equals 10 to the 0, or 1. And in this case, I'll get x equals 10 to the 4th, or I can say 10,000. And if we plug those both back in, it should give us the correct answer. And so this one and this one are both our solutions. All right. Let's move on to example number 4. So example number 4, even though it has a square root like example number 3, our strategy is actually going to be a little bit different. So again, one thing that I tend to do is anytime I don't see a base, I write out what it is so I know what it is for later. If I look at this question, even though it has a square root and maybe looks a little scarier than some of the other ones we've done, the log is already isolated and there's only one log. So I can actually go ahead and write this in exponential form, where I have the thing that's being logged equals the base to the power on the other side. And one strategy we can steal from the previous problem is how to get rid of that square root, and we're going to go ahead and square both sides. So this side becomes x cubed minus 9, and this side becomes 100 squared, or 10,000. We're going to go ahead and add the 9. So we'll get x cubed equals 1, 0, 0, 0, 9. And then I'm going to go ahead and take the cube root of that. And when I do that, I should get about, let me write out that step for you, x equals the cube root of 10009. That could be considered an exact solution. And if I wanted to take it one step further and type it into the calculator, I get about 21.551, and that would be our approximate solution. Good idea to plug it back into the equation to make sure that it works, and when we do, it does. So that is our solution for example number 4. Okay, example number 5. I thought it would be nice to do one that wasn't actually a common log, and in this case, you'll notice that we have that log, natural log, okay? So natural log. And a natural log has a base of e. So it's not going to be base 10 like our other examples. It's going to be base e. Okay, so let's go ahead and isolate our log part first. I'm going to go ahead and I'm going to add 1 to both sides. And then I'm going to divide by that 3. And then I divide by 3. Now, one last thing we could do here, and we've kind of seen this pattern before, is when we have a power, we can go ahead and bring it down as a coefficient for our log. So 2 log of x plus 1 equals 2. And that's nice because just like I divided the 3 in this step, I can go ahead and divide the 2 in this step. So I get natural log of x plus 1 equals 1. And I might even want to write this as log base e of x plus 1 equals 1. So now that I've isolated my log, I can go ahead and rewrite it in exponential form. So my variable that's being logged, x plus 1, is going to equal the base to the power on the other side. And the only thing I need to do to get x by itself is subtract 1. So I'll get x equals e minus 1. Exact solution. And if we enter that into the calculator, we'll get about 1.718 as our approximate solution. All right, folks, let's take a look at one last example here. And that is example number 6. All right, this one, just like the last one, is the natural log. And we know that natural logs have a base of e. We can do our log properties to condense logs if they're a natural log or a common log. That part doesn't actually matter. So I'm going to go ahead and use my product property here to combine those to get natural log of x minus 2 times x plus 1 equals 2. And then I'm going to go ahead and FOIL that out. X squared minus x minus 2 equals 2. And I've got my log isolated. I've got log all by itself. And so now I can rewrite it in its exponential form. So I'll get x squared minus x minus 2, or the thing that's being logged, equals the base to the power of the thing on the other side. All right, now because I want an exact answer, I'm going to leave the e squared in there until the very end. And just like any time I approach a quadratic, I like to move everything to one side, set it equal to 0, to see if I can factor it. And if I can't factor, like I can't in this case, I'm going to go ahead and use the quadratic formula. So x equals negative 1 plus or minus the square root of b squared minus 4 times a times, believe it or not, this whole thing is your c value, negative 2 minus e squared. I'm going to divide that all by 2 times a. And if you simplify that, that'll give you 1 plus or minus 9 plus 4e squared over 2. And if you leave it like that, that's absolutely fine. That gives you your exact answer. But if you want to test and make sure that they both work, probably better to turn them into the 2 separate decimals. One of them will give you negative 2.605, and the other one will give you 3.605. Now, as it turns out, this one, when you plug it back in, does give you an answer, but this one, when you plug it back in, does not. So in this case, there's only one solution to our equation, which is that x equals 3.605. And that, folks, is 4.6, solving exponential and log equations.